Hey guys, do you want to be able to turn big pieces of metal into small pieces of metal with your lathe, but you want it to be really straight? If so, stick around. Hey guys, welcome to the channel. So we have the lathe set up on the table, as you can see. But before we can really start using this lathe, or any lathe in particular, we have a few procedures to run through. On today's video, we are going to check to see if the bedway is true, if there's any flex or twist to the bedway. I'll explain that here in a minute, but first let's back up to what this is and where we're at the moment. So it's very easy to get off track and start rambling. As you've known from my videos, I had mentioned I was going to make an overview video on all the features and things of this lathe, but I want to get good at it first before I make any realistic pro and con videos and show you all the features and everything. This is really the first step you need to do before you even start using the thing. Whether you have a new lathe or an old lathe, once you move it from the spot it's in, you really have to reset everything. Let's say you bought a lathe or got a lathe, you lugged it in here, you either built a table or bought a table, you got your toolbox with all your fancy little gadgets and gizmos you went and got on Amazon because you thought you knew what you needed from all the videos you've been watching, to find out you don't have half of the stuff you need. So the hardest part is done, right? I mean, you've got your lathe in the shop, it's up on the table, you have it bolted down. That's very important. We'll touch on that later. You see mine is bolted to wood. That's not some closely guarded secret. Don't bolt yours to wood. That was a mistake, but we're just going to deal with it for now. You might notice this is a mill head. Well, you can ignore that for now. We're going to ignore that today. I'm actually going to be upgrading this to a full collet system, so that's going to be a later video. So we're just focusing on the lathe portion. This particular lathe does have a break-in procedure. You have to run it at each speed for 10 minutes straight, and then after about 2 hours of use, you want to change the oil out. I went ahead and changed my oil out a little early. I have also made a mess changing the oil. 99% of the time you'll be using the lathe, your mill head's going to be swung out of the way, which is why it's so important to bolt this down, because not so much we're worried about it toppling over, but as I already stated, we're checking for twist in the bedway. So having this massive counterweight onto one side is not going to do us any favors there. So I'm using nylock nuts and lock washers. It goes through all the way down through the table, through the steel. By the end of the year, I will likely have 1/8" steel on top of the wood slipped underneath, and we'll redo this whole procedure. So if you were like me, knowing better, you're going to throw something in the chuck and work on the speeds and figure and turn your first piece of metal, which for me was this junky piece of aluminum. I turned a wheel stud with messed up threads into a piece of aluminum without messed up threads. So I will turn these into something at some point, but I wanted to just try it out. So like I said, using this thing right out of the box without making any adjustments and setting anything up, you might throw a piece of steel or a piece of aluminum in here, and let's say you put a Jacob's chuck in your tailstock and you countersink a longer piece of metal, and then you move everything back down the bedway and you put your live center in the same tailstock you used to counterbore the, well, it wouldn't be a counterbore, countersink that workpiece, and now you're 10 inches down of travel down the bedway, and that same live center doesn't fit, doesn't line up to the hole you just drilled, and it might not make a lot of sense to you. Every adjustment you make to either the bedway or the tailstock has to compensate for the angle of the headstock. Are headstocks somewhat adjustable? Of course they are, but this one really isn't. There's no illustration, there's no procedure on how to do that on this particular lathe. Most of the time the factory gets a pretty good job of aiming this thing the right way. So we're going to leave that. We're going to assume this is fixed, because it mostly is, and move on. So this is actually my 4th attempt at doing this, so I'm trying to be quick. I'm aiming for about a 15-minute video, so let's see how I do. So let me turn your attention to a piece of wood with a nail in it. So imagine our nail is our tool post, and at the top of that tool post at a 90-degree angle, you have your cutting tool. So as you see, when we flex the board one way or the other, the dial indicator moves to the left or to the right. That is somewhat simulating bed twist. So as the whole carriage assembly glides down the bedway or towards the headstock, what we're trying to figure out is if that tool post is being driven into the piece or being pulled further away from the piece. depending on which direction it's heading. Which brings us to the point of today's video. You need to check what the center bore is on your chuck and spindle. Ours is like 1 1/8 inch, so that's just under 29 mil. What I did is I got a piece of 1 inch stock, 3 foot long. I cut it down to 8 inches. Two of those inches are going to be in the chuck, and we're going to have about a 6 inches of overhang. Obviously, if your lathe is a little bit smaller or a little bit bigger, the rule of thumb is you want to get the largest piece of stock that will fit through your chuck. That's going to give you the most accuracy. I'm going to just go ahead and face off the end I cut off. At the moment, we're not measuring anything. We're just roughing this. A little bit of oil. This machine is really designed for high-speed steel cutters, which can cut at a lower speed. Carbide is for much higher RPMs than this machine is capable of. But I've got it pretty much running full bore, and with some oil, these cut pretty well. High-speed steel, you have to sharpen a lot, and I don't know how to do that. So we're going to do this by hand. All right, so that's that end faced off. Now comes a little bit of the tricky part. When you're dealing with, okay, let's say you want to do this procedure right out of the box, right? Your tailstock is not likely going to be centered anyway. So this is kind of one of those, as far as order of operations goes, get your tailstock as close as you can to center, then do this bedway twist procedure, and then reset the tailstock using the same bar as a truing bar, and we will get into all of that. I've set mine up somewhat to be centered. You have most of your tailstocks, you're going to have adjusters to kind of fight against each other to move this to the left or to the right on a horizontal plane, and then your vertical plane you have to shim. In fact, mine is about 8 thousandths too low. Let's go ahead and countersink this side of the piece. Get this out of the way. Always want to make sure you don't back yourself into a corner. You want to make sure you have you can do a full pass without hitting anything or binding anything before you start cutting. Not terrible. So this is what you're aiming for to support the workpiece. Is no deflection whatsoever as the tapers are mating up to their interference angles and all that fancy crap. That's really what you want. Before we start turning, we would lock this, of course, and then, as you can see, that didn't move either. We'll leave this just preloaded a little bit, and you can see how out of round this is. So we're at about 7 thousandths out of round or so. But now watch what happens when we unsupport the end. Got a little bit more. So why it's doing that is because the tailstock is trying to pull the workpiece into its own axis. Versus it's ignoring the line that this is creating at the headstock. So because this is a rough, cold rolled piece of steel that hasn't been turned down yet, it's going to kind of be a bit confusing and throw the readings off. But to illustrate this pulling this workpiece into its own axis, one step further, we're going to spin this to the high point, the low point rather. So like we're right about there. And now watch the needle when I drive the live stock into the taper. It drives it to the point it was before when we rotated this by hand. Remember, we only had like a 7 thousandths out of round, roughly. So it's putting it back It's driving it to its own axis. What we're going to do is go ahead and support this end of the workpiece, and we're going to turn this down to where it's flush, and then we'll go from there. All I'm doing is turning this down until it's concentric all the way around. You can see we're still mostly round at the end now. If we unsupport this, we are still drifting a bit. About 7 thousandths out around, unsupported. We're going to channel this center section out. We're going to go about 30 thousandths. We're going to be machining 2 points right here and right here approximately. So we'll have a 1/2 inch, we'll have a full inch. Alright guys, this is the design you want. And we need to remove the inside here. This is approximately 30 thousandths. Important to mention, you want to cut this groove just big enough for your tool. That was nice and clean. Mine is only a 3/4 horse, so can't really take huge chunks. That happens sometimes. Alright guys, this is the design you're looking for. We've got a 30 thousandths trough in between our accentuated points. So the nervous part is coming up. We have to remove the support from our workpiece at about 6 inches. Turn this, it's nice and round. Yeah, we're like about 10. I'd say about 10.5, 11 thousandths to turn this down. Now we have to turn this unsupported, of course, but you can see at least it's somewhat rigid. But now let's see how out of round this one may or may not be. Much better. The goal is to face both of these sections down until they're perfectly round again without the support of the tailstock. Alright guys, moment of truth. I've got this preset to just skim 1/1000th. I want to see how bad the pattern is on this. Let's go ahead and check something really quick. We're kind of on the 1, 5. We're barely like 4 thousandths out of round now. So let's do something to illustrate what's going on here. See how we're clean? And see how we still have some blue? So that tells us we have a little bit more to go. And so this section is already turned concentric. So we have a little bit, just a little bit more blue. And don't forget, the reason I'm going down to this end too is because we're trying to get an even pass with this piece being unsupported. So our last pass, we took about 9 thousandths off. We're gonna do a final 10,000 pass. Use red this time. Just to illustrate, power might go out. And that is that. And that's what we're looking for. This brings us to the next part of the video, which is the entire point of the video. We need to measure this point on the bar and this point on the bar. That's why they're accentuated. If there's a difference, how do we fix that? So you grab your knockoff Mitutoyo, get it as centered as you can. All right, let's take a look. So you can see we're at the point, we're at 0.9, 5, 20, but we're not quite to the 20. So you would add 19 to the 5.0, which would put us at 0.969. On the veneer scale, we're closest to 1. All right, now let's go measure the other one. We're at the 0.9, 5, 11, 12, 13. We're not quite to the 14, so you're going to add 13 to 5. So you're at 0.963 and 5. So that gives us a 0.0056 difference. So we're between 5 and 6 thousandths off. This is supposed to be a 31-inch lathe of workable space. We're almost at a thousandth drift for every inch. Not great. So luckily, fixing that particular problem is relatively easy. It's a bit trial and error, which is why you need as much space in between these points as possible, because you're going to have to do this a couple times. And also figure out, well, which way does this bedway need to be twisted back to straight? So basically, because this end is smaller than that end, our cutter is being driven into the piece. Coincidentally, that's also probably why I have so much excessive chatter when using my cutoff or my journaling tool, because it's not only driving it in, it's driving it down, because the bedway is doing kind of one of these towards the end. So there's really just two wide points of contact on each side. And really all we're gonna do is shim this back corner here to bring the bedway kind of straight again. So it's almost impossible to sit here and try to figure out the math of the perfect shim to put on in a random spot on that side of the footer. Tightens things up a little bit. Let's go ahead and put a 20,000th shim in the corner and see where we're at. A 10,000th really didn't do much. A 35,000th definitely made a difference. Okay guys, we went from 10,000th, 35,000th. Now we are at 55,000 shims on that back corner. This is the inside lug. 9 and 5 plus 6, 7, 8, 9. I would say that's closer to 5. 9, 5. All right, the outside lug. So 0.95 plus 6, 7, 8, 9, since we're not to the 10, so we're 0.959 and 3. Don't think I need my calculator for that. All right guys, well we got really lucky with only having to do this 3-4 times with the feeler gauges for us to wind up to the tolerance we're at now, plus or minus the accuracy or inaccuracy of our equipment. We're at 2 10,000ths difference between those two lugs now, so that's telling us we're cutting pretty true on our lathe. So to visualize what's going on here, so this is a 1.5 thou shim, 0.0015 compared to 0.0002. So imagine putting this on its side would be its thickness. You take the thickness of that, divide it by 15 parts, and it's only 2 of those. So over just a 6-inch span, to be off that much, I'm not going to lose sleep over that. We're done, but we're not done. I hate to do this to you, but I'm probably the only one that's going to make this a 2-part episode of truing your lathe up. The next step is to do a bit more work on the workpiece and get the tailstock dialed in. But that's going to be the next episode. But guys, if you've made it this far, thank you for watching. This was a very stressful, strenuous video to make because of all the technical jargon and stuff, and it's hard to know the audience of what level everybody's at. Mostly this is just for entertainment, but I want to be helpful where I can be. After 3 failed attempts and 200 gigs or so of footage I get to go through to edit all this, I do appreciate you guys sticking around to the end. We actually had a successful video, I think, but I'm very tired. Guys, I will catch you on the next one.